Welcome to Termite Machine Works. My name is Keith. Today we're starting a project, and this is going to be nothing more than a clamp beam bracket off of a stanchion, an arm that comes out and holds a barbecue. Now everything on the boat is bronze stanchions, rigging, and everything else. So the request is to build a bronze folding bracket for his barbecue. Now that's what we got in the lathe here. We're going to be doing some of that, but I also want to incorporate a tour of my lathe. Now I've got the camera all the way back as far as I can go before the camera's outside the shop here, just to get you the length here. Now I'm not going to be able to pull off the back cover because the spots are so tight, and there actually isn't any room to put the camera back there to show you the gear changing and stuff like that on the back. And basically it's just two gear changings that were put into play to give you an extra coarse thread. This lathe has only got American standard thread capabilities. Now this is a Clausing Colchester, a 17 inch. That's 17 inches over the waist. It also has a gap, and I'll zoom in closer, and the gap pulls out, and we have a 29 inch gap swing in here. Alright, the lathe on the bed here has got the Clausing Colchester Lathe Company machine number 534004. Alright, Clausing Colchester, Atlas Press Company, Kalamazoo, Michigan is on the main tag here. And I'm just giving you side to side here, but here's your levers at the front and levers at the top, your spindle speeds. So in the high range there, this is only about a 900 RPM machine. Most of the time I'm running in low RPM. Even when I'm turning it fast, I'm only in about 450 RPMs here. Alright, the Colchester Lathe Company, Ltd, England. Alright, now this has got a gamut bearing in here, and when I first bought it, the bearings were slightly rust tracked from moisture and sitting. And I ordered a new bearing when I got this lathe. When I bought this lathe, I ordered a brand new bearing, and it took 8 months to get a brand new bearing, a brand new gamut bearing for this lathe. Alright, here's the threads per inch and the feeds. Alright, now what I was telling you about the back cover there, when using 36 tooth driver gear, that's the driver. I chose to leave that gear in all the time because I'm having to cut these threads down here more than I'm having to enjoy the real fine cuts or these threads up here. So I've left that 36 tooth gear in there, and I never change it. So every one of my feeds drops on down. Okay, so I can only go in this square right here. Just meaning that this is a CA adjustment here with a 36 tooth gear in it, and this is the CA here. And then what I did is I just left that gear in there and then verified that 14 would be DA now, 28 would be CB, and 56 would be DB up here. You can't get this top aisle. So by running the 36 gear, everything else drops down and this becomes null and void. And that's how I run this lathe here. Most common, yeah, you asked that, and most common I leave it right in this spot right here, and my the three feeds right here are usually 4.1 or 4 1/10, 8 and 17. The underneath the 12, under the 24, and under the 48, there's the feed rate per revolution. But mostly I'm changing between 8 and 4. 8 and 4. So if I'm hogging or roughing, I'm in about 8 thousandths per revolution, and going for a fine cut would be about 4 thousandths a revolution. And here's your selections right here for your D and C on that one, B and A here, and then your pin location here, and that's basically all you need to ship this. This is engage your feed or your threads and out. Now on your top levers here, you got two levers up here, two positions on that one, two positions on this one here, and then you have a back gear and a top end. All right. That's 450 RPM in reverse, and then basically a back gear, and that's 97 RPMs in reverse. Alright, we're going to drop down to main speed. We'll go ahead and we drop this down, and now we're running at 133. And then the lowest speed, of course, is 26. Alright, now this is direction, engagement of the feed, the total feed from the gearbox. So you got neutral, so you have no drive on your feeds at all. And then this would typically be forward, and this would be reverse. And that's what we're running right now. We're running 450, and we have to reverse the motor and reverse the threads so that we can follow out and use the tracer on the back side. And that's what we're doing. We're tracing some circles to create round spheres on our bronze part here. Okay, this is going to be the end cap. There's going to be a bore going through this where a stanchion of 920 thousandths diameter is going to run through, and there's going to be two bolts going this way. But this is going to be our end cap, so we chose to give this radius, and then we can set this up in the index head, and we can complete the bolt pattern that's going to be used on it. Now we're going to part this off, and I usually take my brush and I hold it over the top of the chips flying to hold them so that they're not flying all over the floor. It kind of keeps them right down on the lathe here. After I got in, go in about a quarter inch of depth, then I go ahead and I break those corners on the now we bring in our radius cutter again. We kind of set up where the leading edge is going to be right there, and we back off our feet a little bit. We don't need it all the way in. We're gonna start out here at the edge anyway. All right, now we're going to advance our rod so that we can radius another end. Same kind of setup. See how it's got a little bit of run. We'll go ahead and put our indicator on it. We're running about 10,000 there, and just try to get it down to at least a couple. One and a half. Test fit. Nice.